Okay, we're off to the races. So we're still working in section 1.6, which is a section on solving other types of equations. And just to recap, but a quicker recap than we did last time. Uh, at this point, we have solved linear equations. Those look like ax plus b equals c, right? Where the highest exponent on this polynomial part is a 1, right? So if you needed to distinguish this kind of an equation from other kinds of an equation, it's just that you have the variable x, or whatever the variable is, could be x, y, z, whatever the letter we choose, but the highest exponent will be a 1. So this is a first degree polynomial, and the exponent also sort of like sneakily tells you how many solutions there are going to be for this kind of an equation. So there can be at least, or sorry, at most one solution for a linear equation, right? And we use the principle of addition, the principle of multiplication to sort of rearrange and jumble up the equation so that we can isolate the x. For quadratic equations, we know that the standard form of quadratic equations looks something like ax squared plus bx plus c equals 0, where there the highest exponent is 2, so we have a degree 2 polynomial, which tells you that we should have 2 solutions at most. Okay, sometimes you have no solutions, sometimes you have only a single solution, but at most we can have 2. Then last time, we started in on rational equations. Now, these rational equations are equations that have algebraic fractions in them. There's not one standard form of these kinds of equations, but in general, they look something like, let's just say 1 over x plus b plus 1 over x plus c is equal to x, something like that, where you're sort of focused on these denominators, because the trick there was that we need to find the least common denominator for these algebraic fractions so that we can cancel out the denominators. Then we sort of simplify the expression that we have after that, and it turns back into either a quadratic or a linear equation. So these revert back to a linear or quadratic equation. The fourth type of equation that we looked at is the quartic equation. And this one did have a sort of standard form. The quartic equation we looked at specifically was in quadratic form. What does that mean? Well, sort of like the standard form of our quadratic equation, we have this ax plus bx plus c situation. But for quartic equations, the exponents on these two terms are different. They're sort of multiplied by 2. At least the powers are multiplied by 2. So we have ax to the fourth, bx to the second power, plus c. But this sort of looks like a quadratic equation. And so we figured out that, okay, this is a fourth degree polynomial telling us we have at most 4 solutions. And the way we solve these, or the only way that I taught you guys how to solve it so far, is that we solve them by using the zero factor property. So the zero factor property, remember, requires you to remember the AC method, and then you set both of those factors equal to 0 once you factored. But here, at the end of this, you will have to solve 2 quadratic equations. which resulted in 4 solutions. Okay, so we covered rational equations and quartic equations on Wednesday. But now we need to be able to solve, was it 3 and 4, 5, which is a radical equation. So those things that have roots in them. And radical equations look something like this. The square root, well, let's just do x plus 3 is equal to x minus 3. Now, we're going to have to figure out how to deal with this radical part of the equation. This is not a polynomial equation. So the exponent that we have here can't really tell us how many solutions we're going to have until we can sort of cancel out this radical expression or the radical symbol. We'll see that this kind of an equation will revert to either a linear equation or a quadratic. So depending on whether it turns into a linear equation or a quadratic equation will tell us how many solutions there are. But then we're going to want to use caution here. We may find false solutions. So there's a weird thing that happens in solving equations sometimes where we end up with a dead end. That is, we get a solution, but for some reason that particular solution is restricted. We've seen some restricted values already, but we'll see that with radical equations, we do need to check our solutions to make sure that they are, in fact, a valid solution. So false solutions, those will exist. And then finally, we'll talk about equations with rational exponents. Okay, and those things look something like x plus 4 to the 1/4 power plus 3 is equal to 0. Just a concrete example there. I'm not using a, b, and c to sort of like replace the numeric parts here. But these numbers will change from problem to problem. And the idea here is that you have this x that's trapped inside of a polynomial that's raised to some weird fractional power. And the key here is that we're going to have to learn how to cancel out the fractional power. So we will cancel the fractional power somehow. And then, depending on the method, we may have 2 solutions. Okay. So I'm being very intentionally vague right now because the only way to really start learning about how these questions feel when we start going through them is to just start in on some example problems. Okay. So let's start with solving radical equations. But let me give you guys a moment if you need to write this down. Okay. Has everybody written this down? All right. Solving radical equations. Okay, so we're given an equation that looks something like this. The square root of x plus 3 is equal to x minus 3. And the idea here is that we need to isolate the x somehow. But currently, on the right-hand side of the equation, this x is sort of freed. It's not wrapped up in any kind of operation, right? You could say that this is x minus 3, so we're subtracting 3 from it. And if we wanted to isolate this x, we maybe could add this 3 over to the other side. But that doesn't really help us because you still have this whole expression that's trapped inside this radical. And so the first step that you want to do here is you want to free the expression that's trapped in the radical. So the radical symbol or the radical operation. Okay. So this particular radical is a square root. Can anybody tell me what operation will cancel out the square root? What is the opposite of taking the square root?
Dividing by it.
Well, you can't divide. You can divide by a number, right? But you can't divide by an operation.
So you divide by the 2 since it's a square root?
Well, you're on the right track, right? So we know that the square root has an index of a 2. But we have to remember that the opposite of the square root, or the inverse of the square root, is raising something to the second power. Right? So you have to hammer that into your head, that in the same way that addition and subtraction are opposites, square root and squaring are opposites. Okay, right? And that should make intuitive sense if you think about this simple example, right? If I have 5 and I wanted to square it and square root it at the same time, well, in the past, we know that 5 squared is 25. So you could say that this is now the square root of 25. But then when you take the square root, you go back to 5. So in some sense, the square root symbol and this square symbol cancel out. So you're just left with the 5. So that's what we're going to do here. But it's not a single number. It's a polynomial expression that's in the square root. But we can treat it the same way. So we have x plus 3 in here and x minus 3. And so if we want to cancel out this square root on this side of the equation, what we'll do is wrap this side of the equation in parentheses and raise it to the second power, because the second power will cancel out the root. Anything we do to one side of the equation, though, we have to then do to the other side of the equation. So I'm going to wrap this side of the equation in the second power. And so now it's balanced in some sense. I've done the same operation to both sides of the equation. Okay. On the left-hand side, the square root and the square will cancel. So now I have x plus 3 is equal to, and this is freed now. We've canceled out the root. But over here, there's no root to be canceled. So what we need to do is just do this operation of squaring the polynomial. Well, whenever you raise something to the second power, you're multiplying whatever's in the parentheses times itself. So what we can do then is say that instead of writing it as squared, we could say that this is x minus 3 times x minus 3. So that's really the second step. So the first step was just to free the expression in the radical by raising it to the second power, and we do that to both sides of the equation. The second step is to rewrite the right-hand side of the equation so that we can multiply that polynomial, right? So square or multiply out the polynomial on the right-hand side. Okay, so over here, I haven't done anything. I have x plus 3. On the right-hand side, if you multiply this out, what should we be getting?
Quadratic equation.
Yeah, it should be a quadratic trinomial, right? You should have x squared when you multiply x times negative 3 is negative 3x. Then we have another negative 3x, so that'll be a negative 6x. And then we should have a positive 9. Okay, so I went ahead and simplified some of that in my head because you will, when you multiply that out, you get 4 terms, but the 2 terms in the middle are like terms, so I combined them. Okay, I'm just not showing that step. But if you were to go from this step to this next step, I would know what you're doing. What you could do to make it very clear to me what you're doing, you could just draw these arrows here. X times x is x squared. X times negative 3 is going to be negative 3x. Then we have negative 3 times x, which is another negative 3x for a total of negative 6x. And then negative 3 times negative 3 is positive 9. Okay, so now it looks like we have a quadratic equation, right? I'm sort of ignoring everything up here now, right? Once you go to the next line, don't look back. If you look back, you're probably going to confuse yourself. So if this looks like a quadratic equation, we need to get it in standard form. So if it's a quadratic equation, then we need to solve the quadratic equation the way we know how. So solve the quadratic. What I can do is subtract this x and subtract this 3 from the left-hand side. So I'll have 0 is equal to, and I'm going to subtract the x here and subtract the 3 here. So that now I have x squared minus 7x, and then this will be plus 6. Does anybody have any questions up to this point? Okay, now, and this is sort of why I said that the test 2 retake is going to be really helpful for you on test 3 even, because we're always coming back to solving either a linear or quadratic equation. So here, you can use whichever method that you prefer, right? On these, I'm not going to care whether you use the zero factor property, whether you use the quadratic formula. Just use whichever comes fastest or which comes natural to you. In this case, I would say what the strategy that comes natural to me is to factor. And if we wanted to factor, we could look at the factors of 6. That's 1 and 6, and that'll definitely give you 7. So we can use these, call them both negative, break this up so that we have negative x and negative 6x, drop our other terms down. Then we can factor by grouping. These two terms have an x in common, so we have x minus 1 here. These two have a 6 in common, so I'm going to factor out a negative 6, have an x minus 1 there as well. So I'll have x minus 1 and x minus 6 equals 0 because we have the zero factor property to apply now. So x minus 1 equals 0 or x minus 6 equals 0. So that tells me that my solution set, if I solve these linear equations, will be positive 1 and positive 6. Does anybody have any questions there? Okay. Well, with radical equations, I said that they will revert to either a linear or a quadratic equation. In this case, we saw a quadratic equation. But we need to use caution with these solutions because we may find false solutions. So with radical equations, we have to check them. And the way we check any equation is to take our proposed solutions or our potential solutions and substitute them back into the original statement to see if we get a true statement. Okay. So let's do that. So we have our original statement, our solution set, or our potential solutions are +1 and +6. The original statement was that the square root of x plus 3 is equal to x minus 3. And we're going to have to check both of these solutions, so I'll write this out twice. So first, I'll take my first solution, and I'll substitute it in for x. And I'll see if I get a true statement. So I'm taking the square root of 1 plus 3 to see if that's equal to 1 minus 3. Well, that's going to be the square root of 4. And this will be -2. So the square root of 4 gives us a +2, but that's not equal to -2. So since this is not a true statement, then we have to throw away x cannot be equal to 1. So in some sense, we have to throw this solution away. That one does not work. It's not valid. But we'll do the same thing over here and check to see if 6 works. So we'll have the square root of 6 plus 3 and see if that's equal to 6 minus 3. So I'm going to put little question marks because I'm not sure. And it turns out that this is going to be the square root of 9. 6 minus 3 is going to be 3. And the square root of 9 is 3. So that one checks out. So that one is true, which means that x does equal to 6. And that one is a valid solution. So the solution set only contains a single value, and that's just 6. Okay, does anybody have any questions? All right, let's look at some more example problems. So what I want you guys to do is solve this radical equation and try to sort of mimic what you saw on the last problem. Okay, so the square root, this time we have 3x plus 10 in the square root, and that's equal to 5 minus 2x. Okay, so as you write that down, what I'm going to do is make some breakout rooms, just 2 of them. This looks good. Okay. I've sent invitations for the breakout room, so go ahead and accept those once you've written this down, and then work with your classmates to try to figure out what the solution to this equation is. Okay. So we're waiting for everybody to jump back into the main session. I know that it's a little bit daunting for me to give you only one example problem and then throw you into sort of the deep end with one of these. But I think that the form of this particular problem is really similar to the last problem that we worked. So I did expect a little bit of turbulence, but I sort of had confidence that maybe you'd be able to get over that hump. So when you're solving a radical equation, the first thing that you want to do is make sure that this radical expression over here is isolated. Because once it's isolated, we can take the square of both sides of the equation to cancel out the square root. Now you might notice that I'm saying square and square root a lot, and it sounds like I'm just saying square, 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 right? Because they sound really similar. So make sure that you know what I'm saying, or if I'm going too fast or it sounds like a bunch of mumbo jumbo, that you just like stop me, okay? But we want to isolate the radical expression, which in this problem it was already isolated. Then we want to take the square of both sides. Another way of saying that is that you want to raise both sides of the equation to the power 2. Okay, now the reason why we're using the power 2 here is because the index of the square root is 2. Now, if this was a cube root, for instance, let me get a pencil out. If this was like a cube root and there was a little 3 right here, then what power would I need to raise both sides of the equation to?
3?
Yeah, to the 3rd power. It's definitely not a trick question. You just have to remember that the root or the radical, that its index, so whatever root we have, its opposite, the thing that's going to cancel it out, is raising the expression to that same power. So that's why when we see this problem, we said, okay, square root, so we need to raise everything to the 2nd power. So I'll wrap both sides of the equation in parentheses, and I'll raise everything to the 2nd power. The 2nd power on the left-hand side will cancel out the radical. And again, in my head, I sort of think of this in a silly way. The 2nd power breaks all of this expression out of prison, right? So it's imprisoned or it's trapped inside the radical. But once you square it, you turn the key and then that stuff is released. There is no longer a radical symbol because the square operation has canceled it out. On the right-hand side, you have to be careful because there's no radical symbol that's being canceled out. So that for our next step, we're going to have to multiply this polynomial, right? And remember that raising something to a power of 2 is multiplying it by itself. So we might want to write this differently as 5 minus 2x times 5 minus 2x. And then we FOIL that out or multiply it out the way we do polynomials. Nothing's going on over here. We're just going to rewrite 3x plus 10. And then we can go ahead and multiply this out to 25. Multiply that out to negative 10x. Multiply that to another negative 10x. Multiply that out to a positive 4x squared. Any questions up to this point?
No.
Okay. Well, now it's starting to look like a quadratic equation because we have a squared term. So we're going to want to clean this up and get everything over to one side. So one thing I might start by doing is combining these like terms because we have two x terms, and then sort of rearranging this. So I might rearrange this to 4x squared, put this in the front. I have my x term that comes next, which will be the negative 20x. And then this is a positive 25, so I'll put plus 25. And that's all equal to 3x plus 10 because I haven't moved anything yet. But once you're ready to move some stuff, we've simplified this side of the equation. We're going to say, okay, let's move this 3x. So I'm going to subtract 3x over here. I'm going to subtract 10 here and subtract 10 here. So this stuff cancels out, and that's how we get a 0 is equal to 4x squared. This should be minus 23x, and then we should have 15, positive 15. How are you guys doing so far? Well, now that we've multiplied the polynomial and simplified, our last step is going to be to solve the equation, and this time it's a quadratic equation. So would you guys want me to solve this by factoring, or do you want me to solve it by using the quadratic formula?
Let's do factoring.
Okay. Yeah, I always solve it by factoring because, well, it's good practice, right? Because the AC method just keeps on coming back. So it's called the AC method because we need to do A times C. In this case, that would be 4 times 15. So that will give us 60. So we need to look at all of the factors of 60 to see which ones will add to make 23. Okay, I'm sort of ignoring the sign because I know I need to get to 23 somehow. So here I might skip all of the factors that we start off with, like 1 and 60 won't work. 2 and 30 won't work because that'll be like 32. But 3 and 20 would work to give me 60, right? And then I need a positive 60, so that means that both of these could be positive or both of them could be negative. So I need both of them to be negative to give me positive 60 and to give me negative 23. So that means that I'm going to change this expression to 4x squared minus, you might put the 20 first. It really doesn't matter where we put these terms. Let me just put the 3 first. So 3x there minus 20x there plus 15. Then we're going to look at the first two terms, and they have an x in common. So we have x there, leaving us with 4x minus 3. And then we can factor out a negative 5 here, which will give us an x plus, no, the 4x. And then I need a minus 3. There we go. Now these match. So my factors are 4x minus 3 and x minus 5. And that's all equal to 0. Does anybody have any questions about that part? So we're using the AC method here. Well, now that we have this in this form, we can just solve this using the zero factor property. So the zero factor property says that if we have 4x minus 3. And this was x minus 5, if I recall correctly. And these two things are being multiplied to give us 0. That means that either 4x minus 3 is equal to 0 or x minus 5 is equal to 0. This right-hand equation, or the equation that I've written on the right-hand side, is really straightforward. It's just a linear equation that we can move the 5 over, so we get x is equal to 5. And then this one, we can move the 3 over and get a positive 3. That's equal to 4x, and then divide by 4, so we would get 3 over 4. But I'm going to put a little cloud around these because we need to check our solutions. These check the potential solutions. So when we check those solutions, we have to go back to the original equation and plug them in. So we have the square root of 3x plus 10 is equal to 5 minus 2x. And we have to do this twice. 3x plus 10 is equal to 5 minus 2x. So on this side, we're going to want to simplify this expression with the fraction inside. But I'll save this one for later. It'll be easier for us to solve this one. 3 times 5 plus 10 is equal to 5 minus 2 times 5. So this, if we start to simplify the left-hand side, will be the square root of 15 plus 10, which is the square root of 25, which is 5. Okay, no square root. This side we'll get 5 minus 10, which is negative 5. So we'll ask ourselves, is 5 equal to negative 5? Oh, and you guys can't see that. So since these are not equal to each other, and that's a false statement, then this solution does not work. You don't have to check them by hand. You can totally check them in the calculator, and that'll cut down on some time. And usually I like to do some razzle dazzle here to impress the viewers at home. But you could just do these in the calculator, right? So what I would do is just type into the calculator the square root and then put this expression inside the square root. So let me see if I can zoom in. I have 3 times 3 over 4, and that's the same thing as 3 divided by 4, plus 10. I get 3.5. So I'm just going to write this as 3.5. It's okay when you're checking if you get a decimal number, because we're just trying to see if the value comes out to be the same. Okay. On this other side, you'll do the same thing, 5 minus 2 times 3 divided by 4. And you get 3.5 as well. It's exact same number, exact same sign. So that is a true statement. Which means that your solution set, if I zoom out, your solution set for this one only contains one number, and that number is 3/4. Any questions, comments, or concerns about that kind of a problem? Okay. Well, let's do one more radical equation, because not all of the radicals are going to be square roots. So let's solve this radical equation. The cube root of 4 plus 6x minus the cube root of 1 minus 8x is equal to 0. Does anybody have any suggestions for what the first step for this problem should be?
So put in powered 3, both roots.
Yeah, and it turns out that actually that's going to be our second step, right? Our first step is always to isolate the radical expression. And what I mean by expression here is terms. So it looks like we have two radical terms here. We have this cube root of something, blah, blah, blah. Don't really worry about what's in there. You just know that you have a radical expression wrapped around some symbols, minus some other radical expression. So there's two of them. But when I say we need to isolate them, what I mean by that is that we need both of them on one side of the equation or the other. They can't both be on this side of the equation. I mean, they could, but I guarantee you that if we solved it that way, it would make this way more confusing than it has to be. Okay, so what you sort of want to do is, if you have this expression and you're subtracting some other expression here, and that's equal to 0, well, why don't we just use our principle of addition to move this guy over here to the other side of the equation. Now, keep in mind, whatever this expression is, I know it looks complicated, it looks bulky. It's just a number. So we have some number minus some other number, which means that if we were subtracting a number here to move it to the other side, you could just add that same number on both sides of the equation. So what we could do is add the cube root of 1 minus 8x to both sides of the equation. So that they cancel out here, and you end up with this equation, the cube root of 4 plus 6x is equal to, well, 0 plus anything is just whatever that thing is. So we have now, in essence, moved that other radical expression to the other side. Now I know that feels strange, but really it's the addition principle. If you're adding something to one side of the equation, you can do it to both sides of the equation and everything is still cool. Doesn't matter how complicated that thing is. You can always add or subtract that thing to both sides of the equation. But now we can go ahead and cancel the cube root. And that's basically because the cube root is the opposite of raising something to the third power. So what we can do here is, I'm going to just rewrite the problem. 4 plus 6x in the cube root of 1 minus 8x. Throw some parentheses around both sides of the equation, and then raise both sides to the third power. Well, this one is actually really nice because you have a radical that gets canceled on this side. So this cube root cancels this cube. This cube root cancels this cube. So what you're left with is just 4 plus 6x is equal to 1 minus 8x. Does anybody know what kind of an equation that is? Well, if you look at the x's, what's their highest exponent?
1.
Yeah, it's just 1. So that tells you that it's a linear equation. So we're just solving for x. We're just trying to get x by itself. So we might add 8x to both sides. So we would have 6 and 8. That would be like 7 and 7. So that'd be 14. Plus 4 is equal to 1. And then you could subtract 4 on both sides. So you get 14x is equal to -3. And then you could divide the 14 over to the other side. So you get x is equal to -3 over 14. Remember, the fourth step is to always check your solution. Just be careful when you check this in the calculator. If you do use the calculator to check it, it's a fraction, so I recommend the calculator. But these are cube roots, so we have to be very careful. We need to, you go to math, select the cube root, 4 plus 6 times -3 over 14. So that's this expression here. Then we're going to subtract this guy and see if we get 0. So another cube root. And then this time we have 1 minus 8 times -3 over 14. Okay, so we're trying to get 0 here. We did get 0, so this solution works. Okay, do you guys want to work another example that's like this?
Yes, please.
Okay. Solve the radical equation. Cube root of 4x squared minus 4x plus 1 minus the cube root of x equals 0. Okay, I'm going to give you guys about 5 to 10 minutes to work on this equation. And if you have any trouble, I'm not going to throw you in breakout rooms this time, but if you have any trouble, ask your classmates, and I will be right here to answer any questions you have. Resume the recording. So once we've isolated our radical expressions, we can raise them to the appropriate power so that we cancel out our power and our radical. That will leave us with whatever expression is left over. It basically frees us from the radical. So we have 4x squared minus 4x plus 1, and that's equal to x. Well, here, there's nothing really to simplify in this particular problem, except that this is beginning to look like a quadratic equation. So we need to solve this the way we solve quadratics. And the first thing I might need to do is get that into standard form by subtracting this x over here. Keep this as 4x squared minus 5x plus 1, and that's equal to 0 now since these x's canceled out. And then we might try the zero factor property, which means we need to use the AC method to factor this. So 4 times 1, AC is going to be 4 times 1, and that's 4. So we'll look at the factors of 4, which are just 1 and 4, 2 and 2. And we need to use these factors, keeping them both negative, so that we can get a positive 4 when we multiply, but we can get this negative 5 when we add them. So we'll go ahead and split this term up into negative x minus 4x. If you put them in a different order, it should not change your final result when you factor. So I'm just going to bring these down. And some of you might have put the 4x first. That's fine. We'll get the same thing. These two have an x in common, so I'll factor out an x, leaving me with 4x minus 1. These two don't seem to have anything in common. But any two numbers that you can think of have a factor in common, and that factor is always 1. So I could, if I wanted to, factor out a 1 here, and then call this 4x minus 1 in here. And you'll notice that if I multiply this out, negative 1 times 4x does give you negative 4x, and negative 1 times negative 1 does give you the positive 1. So you can either switch the order of these two terms if you wanted to avoid that sort of weirdness, but in any case, you'll get the same two factors. You'll get 4x minus 1, and you'll get x minus 1 equals 0. We can then use the zero factor property to say that 4x minus 1 is equal to 0, or x minus 1 is equal to 0. But in any case, we get two solutions. This will be 1 over 4 when you solve that one, and then this one would be x is equal to 1. So we just need to make sure that we check these solutions. By plugging them back into the original equation. And I'll leave the checking to you at that point. It turns out that in this problem, both solutions are acceptable. So there's our solution set. Does anybody have any questions? Okay, well, let's go ahead and take our regularly scheduled 10-minute break. We'll come back at 2 o'clock, and we'll start in on the next kind of equation. Okay. Okay, so hopefully we're making our way back to our seats, because we're going to start working on the next kind of equation. But before we do that, did anybody come up with any questions as they were away for the last 10 minutes? Sort of thinking about all of the mistakes in life that led you to this moment. Did anybody have any questions about solving radical equations? Okay, because the next type of equation that we're going to look at is equations with rational exponents. And so there's going to be two strategies to solve these. The first strategy is going to be use this property. So use the property that, let's say, x raised to the n over m power. So if we have a rational exponent, we can always change that expression so that it is now a radical, where we now have the mth root of x to the nth power. Sometimes converting it from a rational exponent to a radical expression or radical equation will help us, because then we can just solve that kind of an equation the way we were solving our radical equations just a moment ago. But usually the most straightforward way to solve an equation that has a rational exponent is just recall the fact that if I have, well, two facts. The first fact is that if I have x raised to some power and then it's raised to another power, that those powers are multiplied. And so if we sort of think about wanting to cancel out a power, then we could think about having something raised to a power and then raising it to the reciprocal power, because using this first exponent rule, we know that we can then say that this is x raised to the n times its reciprocal, and anything times its reciprocal is just 1. So that really cancels out the exponent. And then we can start to solve that equation for x, or whatever this expression happens to be. Right now, it's oversimplified by just using the variable x, but this could be a larger expression in the same way that we saw larger expressions inside a radical symbol, right? But as we jump into some of these problems, these are the two main strategies that we're going to need to be thinking about to cancel out our rational or our fractional exponents. Okay, so let's jump in. Let's say that we had, oh, it looks like I didn't rip these. Okay. Let's say we have this problem. We have to solve the equation. And most of the instructions at this point are going to be solve the equation. You're going to have to be able to decide by looking at the type of equation, what kind of equation is it. But we have x plus 4 in parentheses, so we have a larger expression raised to the 1/4 power, and that's equal to -3. So as I tend to do, I like to say step 0 is really identify the kind of equation. Because if you can't identify the type of equation, then you're probably having a hard time getting through basically figuring out what the next step is, right? What is even the first step? But in this case, what I would turn my attention to is that I have something that's like an expression here, and it's raised to some fractional power. So that tells me that I have rational exponents that I need to deal with. And we're starting to get to this place where it should feel very familiar that if we want to cancel something out, we have to do something to both sides of the equation, right? That idea should feel familiar. We might not know exactly what we need to do to both sides of the equation, but we have to determine what is the thing that we're trying to cancel out. Okay, so right now, I would say step one is that recognize we're trying to cancel out the rational exponent. There's a couple of ways you could do it, right? Those two strategies I said. So either we could use this property to change our rational expression or our expression with rational exponents into a radical expression, or we could cancel out the power by raising both sides of the equation to its reciprocal power. So here, the reciprocal power, we can cancel the powers or the exponents. So if we apply a reciprocal power here, that might be the most straightforward way to do it. So we might apply the reciprocal power to both sides of the equation. So what is the reciprocal power of 1/4?
Four.
Yeah, it's just 4. So in this case, because we have a 1/4 power, what we're going to want to do is basically, I'm using brackets here instead of parentheses just to differentiate the shapes. But I'm basically putting parentheses around this side of the equation and around this side of the equation because I'm going to raise both sides to the 4th power. Again, why are we doing this? We're doing it because we want to cancel out this exponent with this exponent so that this expression becomes just x plus 4. Does that make sense, or is that a little bit confusing? Or maybe it makes sense, like the logic makes sense, but when you have to do it on your own, maybe it'll be a little bit intimidating. Okay, but in any case, if you can walk yourself through that logic, that the reciprocal power will cancel out this power, well then we're freeing up this expression so we just have x plus 4. But notice that there's no exponent on this side. So this side does not cancel out any of the operations. We're going to have to just go ahead and simplify -3 raised to the 4th power. So what you might do there is just, you might remember that -3 to the 4th power is -3 times -3 times -3 times -3, and do that by hand. Or you might just grab your calculator. You might just throw some parentheses down, and we have -3 inside the parentheses, if I could get my fingers to work with me here. And then raise that to the 4th power, and we get 81. So we're simplifying that so that we just get 81. And ¿sabes qué? We just have a simple linear equation now, right? So step 2 is solve the equation. In this case, we're solving a linear equation. And to solve linear equations, we're just going to move stuff around and isolate the x. So all I'm going to do is subtract 4 here, subtract 4 here, and x is going to be equal to 81 minus 4. You take 1 away, you're at 80, and then you take 3 away, and you're at 77. And then just because I don't trust my brain, 81 minus 4 is 77. That's our solution. Step 3 maybe is to check your solution. So what we might do is use the calculator to say that this is 77 plus 4 raised to the 1/4 power. And we got 3 for some reason. Why did we get 3? Did I do this right? Why is this not correct? 81. Stand by while I examine these technical difficulties. One power. -3 times -3 times -3 times -3 is going to be 81. It's positive. Then subtract the 4. Interesting. Let me just take a quick detour, double check myself. So I'm not doing any special math. I'm just looking it up in the key to make sure that we're good. Okay, yeah. All right. No mistakes were made. When we plug this into the calculator, we got +3. So that is 77 plus 4. When you take that to the 1/4 power, what you get is +3, but this is not equal to -3. So that means that we have a false statement. Which means that this potential solution is not correct. What that means, though, is that there's no solution for this particular equation. So that would be your answer, that there's no solution. Does anybody have any questions about that one? Maybe we want to work on a problem that actually does have a solution, though. Because I find that students feel like it's a little bit anticlimactic whenever we work a problem that does not have a solution. So let's take a look at another one. Maybe something that looks like solve the equation x to the 2/5 minus 9 is equal to 0. Okay, well, expressions with rational exponents are the same thing as radical expressions. They're just written in a different notation. So like if we wanted to, we could rewrite this as a radical expression. But what I want you to understand here is that I'm not necessarily going to write this as a radical expression. I just want you to understand that if we wanted to cancel something out here, just like with those radical expression solutions, we had to isolate the radical expression. So the first thing we want to do is isolate the thing that we want to cancel out. And we want to cancel out this operation, this 2/5 power. So isolate the term or the expression with the rational exponent. So you might want to move the 9 over to the other side. So if we do that, we'll have x to the 2/5 power is equal to positive 9. Is everybody okay with that? Okay. Well, then, to cancel the fractional power, so the 2/5 power, raise the equation, so both sides of the equation, to what power?
5.
5 over 2. We want to use the reciprocal power. So I'll write the equation down. We'll throw parentheses around both sides. And we're going to raise this to the 5 over 2 power on both sides of the equation. Remember, we're trying to cancel out this power so that we get x by itself. And when you multiply a power times a power, you get to multiply those powers. So 2/5 times 5 over 2 would be 10 over 10, which is just 1. So we can say that that cancels out to just x to the 1 power. We still have to deal with 9 to the 5 over 2 power. And there's 2 ways of doing that. Well, there's probably 3. But you could throw this into the calculator, or you can use the property that this fractional power is both a radical and an exponent. So what I would do is either use the calculator or remember that x to the n over m can convert to x to the n power, but the m root of it. So this top number is the power. The bottom number is the root. And it doesn't matter what order you take those operations in. You can do the root first if it's easier, and then apply the power. In fact, a lot of times I'll recommend that because if you take the root of 9 first, the square root, or the second root, of 9 will be 3. It'll be a smaller number. So we would have x is equal to, you could call this the square root of 9, since we have a 2 as our root. And then we can deal with the power later. That would give us 3 to the 5th power, which then we could just multiply 3 times 3 times 3 times 3 times 3. Or at some point you might just say, okay, let's just grab the calculator and do that. 3 to the 5th power is 243. However, there is one consideration that we have to take here. And that is, we're taking a square root. So basically, right here, when we applied the 5/2 power, we're applying a 5th power and a square root. And if we take the square root of both sides, then we have to have a plus or minus because of the square root property. So technically, when we take this square root, we need a plus or minus in front of this number that we're going to simplify. So really, this is plus or minus 3 to the 5th power. So we should get plus or minus 243. That feels like I just made something up, right? It doesn't feel natural. It's just like, oh, you're just throwing this in for no reason. Well, let's walk through this. We were solving this expression here, x to the 2/5 power minus 9 is equal to 0, right? That's our equation. We can move the 9 over to the other side and call this x to the 2/5 power is equal to 9. And then we can think about this as just having a rational exponent, or we can think about it as a radical. If I wanted to change this side to a radical, what I would say is that this is the 5th root, right? This is the power, the 2 is the power, this is the root. So what I would say is that this is the 5th root of x squared, right? And that's equal to 9. If you wanted to write this as a radical and then slowly undo the operations, you could and take more steps. And I bet that that would make more logical sense, right? Or it would feel a little bit more natural. Because all we're doing is using that property that I said, that if you have a fractional power, that can convert into the nth root of x to the n power. That's all that we applied here. Does that feel like, I'm not trying to trick you here? That's just a straight application of this property. But now what we can do is say, like, okay, I'm trying to cancel out a 5th root. Well, with the 5th root, we can cancel out the root with the 5th power. So we could raise this to the 5th power, raise this to the 5th power, for sure. But 9 to the 5th power is going to be pretty large. So we're just going to have a little bit of faith that we're going to get to the same place. And we have 59,049. 59,049. On the left-hand side, the root and the power cancel out, which leaves you with a quadratic equation. X squared is equal to this large number. Well, because we have a quadratic equation here, we can solve it using the square root property. And if you recall what the square root property is, and that is if you have x squared is equal to some number that, and you guys can't see this, that basically you can take the square root of both sides, like so that you can cancel out the root and the power here, but you get x is equal to plus or minus the square root of whatever this number is. You have to remember that plus or minus because of the square root property. So when we take the square root of this guy and this guy, we're going to need x is equal to plus or minus whatever the square root of 59,049 is. Well, if I take the square root of that, 59,049, you get 243 here, both the positive and the negative solution. Did that make a little bit more sense? It sort of felt like I threw it in there, right, when we worked it that last way. So here's the compromise, right, that's being made. You can either solve it a little bit more slowly with more steps, and it sort of feels like logically it makes sense in a natural way because we're applying the square root property that we learned when we solved quadratics. Or you could solve it quickly using this reciprocal power idea, but if your reciprocal power ever has an even number in the denominator, then you're taking an even root, which means you need to use a square root property and have a plus or minus as part of your solution. But the choice is really yours. So let's do one more. And I'll sort of give you the freedom to choose which way you want to go about solving this. So we want to solve the equation x to the 3/4 power minus 8 is equal to 0. So use the strategy that we just used on the previous problem to try to solve this one. And then watch out, if you do take the square root of both sides, then you'll have to use the square root property, and that requires the plus or minus symbol. But if you take an odd root, you don't need to worry about the plus or minus. So I'll give you guys about 5 to 10 minutes to solve this. You guys ready to go over this one?
Yes.
Okay. So you might notice that it's getting a little bit harder to give you like a set of steps that you can just run through for each of these different kinds of equations, because we have more equations, and really you just want to feel your way through it, but you have to remember the strategies that came before. So when you're starting something like this is, I can only tell you how I view these kinds of problems. And that is that when I look at this problem, I know immediately that I want to isolate this guy. So like I'm zeroing in on getting this guy by itself. So I'll move the 8 over to the other side to make it positive. And then the equation looks a lot simpler in some sense. And then I have to ask myself, do I want to go down the route of using the reciprocal power? Or do I want to go down the route of writing it as a radical expression? Because easily we could say x to the 3/4 if I were to raise that to the 4/3 power, then I could just cancel out the powers, and that'll leave me with x. And what I could say is if I applied, this is an odd root, that bottom number that I'm applying is an odd root, so I don't have to worry about the plus or minus symbol because it's an odd root. Or I can say that x to the 3/4 power, let's just convert that to the 4th root of x to the 3rd power and go through that rigmarole. So those are the two general strategies when you're approaching an equation that has a rational exponent. So which one do you guys want me to go through? This would be converted to a radical. Or do you guys want me to do both? Okay. So with the reciprocal power, it's really nice. You just say x to the 3/4 power is equal to 8. And then you have to say, okay, I'm applying the 4/3 power to both sides of the equation. And because you are doing something, you need to be aware of what you're doing, why you're doing it, how it affects the problem. This is a power. This is a root that you're applying. But because my root is an odd root, I don't need the plus or minus. So I can just say that my reciprocal powers will cancel out. I have x is equal to 8 to the 4/3 power. Again, I don't need to worry about a plus or minus because my root is odd. So I can simplify this by hand, or I could just throw this in the calculator and call this 8 raised to the 4/3 power, and you get 16. So x is equal to 16. I always put this in a bubble if I'm not sure if that's going to be the final answer. So what I might do is plug this back into the original and see if I get 0 when I subtract 8. So I might say that this is parentheses 16 raised to the 3/4 power minus 8 is equal to 0. Well, that's a true statement. It makes my original equation true. So this has to be a correct solution. So my solution set contains the single number 16. Does anybody have any questions about that method? Okay. Alternatively, if we were solving that exact same equation, you'll start off the same way. You want to isolate the variable. So we have x to the 3/4 power is equal to 8. And then we'll want to convert this to a radical by acknowledging that this is the 4th root of x to the 3rd power is equal to 8. So we'll raise both sides to the 4th power so that we can cancel out this root. You have x to the 3rd power is equal to 8 to the 4th power, which will be x is equal to whatever 8 to the 4th power is, 4,096. And then we have to deal with this cube by taking the cube root of both sides, sort of like the square root property, but because it's an odd root, we don't have to worry about the plus or minus. The cube and the cube root cancel, leaving us with just x. And then we can just take the cube root of this big number. So math, cube root, 4096, and we get 16, which we've already checked is the correct solution. So you get to the same place. The laws of mathematics are consistent, right?
And how do you type that into your calculator again? The cubed root of 4096?
So if you have a calculator like mine or the app that's similar to this, then usually you hit the math button and you go down to the cube root option, which is 4 on mine.
Okay.
And you hit enter. And so you have the little 3 index for your radical. Any other questions? Okay, well, I know that was a lot. That's why the homework is still open if you want to jump in there and get that done. The due date is in MyLabs Plus. I believe it's set for tomorrow at midnight. And then on Wednesday, when we get back together, we'll work on some more of these problems. Any of the problems that you have trouble on in the homework, write them down. We'll start class with those problems, and then I'll have some select problems out of this workbook, and we'll go through those as we review for the test. And just bring your any questions you have, bring those, okay? And what I recommend is that, like, before class, maybe 5 or 10 minutes before class, that you review some of the problems that we did today, just so that you get the juices churning and you're not like having that jet lag a little bit when we start up and then things just like ramp up really quickly, okay? So if you have any questions about that, about next time, about the test, or the test to retake, you're more than welcome to hang back and then we can chat about that. But if you have no questions, you're more than welcome to enjoy the rest of your day.
Thank you.
Yeah, I'll see you guys later.
Thank you.
Thank you. So the retake is